Good morning, this is Alan Peters and Martin Piper of TBA Software. They develop lots of games and lots of a filing system and some game development software in the mid-90s for the Archimedes range of computers. They're going to take us through various games and the utilities they developed and tell us a bit about themselves this morning. Over to you guys.
Okay, thank you very much, Dominic, and thank you, Dave, as well, for inviting us to speak during this session. Okay, so this is the story of TBA Software with Alan and Martin. I'm Martin. Alan is the other guy in the very smart blue shirt at the moment.
I don't know why I've got a shirt on, but I have.
No, I don't know either. Well, actually, so, I live in Singapore, but Alan lives in the UK still. So we're actually at different ends of the world. So TBA was mostly these people here. So Matt Dawson was the founder of the original TBA software. Matt was the original designer and very good at the front of house, and originally worked with another programmer, Jamie Bryant, on Axis. Alan Peters, I'll let Alan introduce himself.
Yeah, so Alan Peters, just as a sort of set the scene, so I've known Martin for, well, forever really in my life. I think we've known each other since we were 3 years old. We've ended up, obviously, Martin's in Singapore, as he said, and I'm in Bristol, as anyone who knows UK accents will pick up immediately, the city centre of Bristol. I invested in TBA after meeting Matt. Became the co-owner, and as we can see on this slide, was one of the programmers, invested, ran the day-to-day operations. It was kind of my first foray into running a business, and it's what we hope to do today, I think, is just tell a little bit of the story of TBA came about and the various things that happened along the way. I would say as well, before we get stuck in, obviously Matt, I'm sure Matt would have joined us, but he's not been very well, unfortunately. He's been a bit of a victim of the pandemic, so he is recovering, but I'm sure everyone wish him well, and maybe if there's a follow-up in the future, I'm sure he would join us. But okay, and I'm Martin Piper. I'm also kind of listed down as co-owner, but I mostly did the programming and math stuff, and just really loved helping out with computer shows. As Alan said, he was the one that took over and ran most of the day-to-day operations from his house. Okay, next slide. So this is the software chronology of TBA software, as much as we can remember. So it started off in '93 with Axis and Dragon Ball, and then, as we'll go into the story a little bit later on, Alan and I got involved from 1994 onwards. I think this list is correct. There's actually a story there where, when we were looking through some of our old games, we actually found one other game that was mentioned, but we couldn't find any reference of it anywhere within our archives, right? So there's at least 2 unreleased games that we can, well, one unreleased game that we'll go through in this presentation, but there was another one referenced later on. So it was, the company, wound up eventually, because as Acorn was going through its little troubles, eventually, these things, I wouldn't say die a death, they just gradually fade out, right? And that was around about 1997. But it was a good innings for, a small little games company. It's a lot of experience in trying to run a small business, for sure.
Probably became an expert in how not to make any money during this this period. But we certainly the computer shows, which we'll talk about a bit, were always good fun, and we did a few crazy things along the way with building ridiculous games arcade type stands for no commercial reason, because it was like a hobby and something to do, I think. So yeah, lots of good fun along the way. The odd bit of controversy and various other things that I'm sure will come up, but yeah, sort of, I think probably for a lot of people in the community around in the Acorn space, there's a lot of sort of happy memories really from that time. And as we'll talk about, as our careers have moved on over the years, there's a lot of things we learned, I'm sure, that have been amazingly useful subsequently. So, right, back to you.
Thank you, Alan. So this is where it all started for us, really. We were racking our brains last night, actually, trying to remember exactly the sequence of events, but what we do I clearly remember, and Alan also kind of clearly remembers too, is that it was 1993 at Acorn World in Wembley. I think it was in October. The TBA stand is down here in the little circled area down here. I think it's too small for me to actually see now, but what was it, 93B or something like that, I think. So, yeah, it was actually the show when there was a prototype 3DO, which was one of the games machines that was using an ARM processor at the time. It wasn't a particularly popular games machine, but it was certainly a games machine which impressed me when I was looking at it, because it had really good 3D graphics for, at that point in time. Alan and I were hawking our prototype games around the various stalls. And at the time I had just finished my A-levels and I didn't have a job, but Alan was working already. And TBA, who was showing Axis, which is, it was a roto-zoomer shooter. They got interested in some of the demos that we were showing during this show.
Yeah, I mean, I recall a little bit of that show for sure, but I say a lot of it was you either pimping yourself around or one of your demos at the time. But yeah, we got a lot of attention with the demo, which which was similar to Starwing, and that I guess proved to be the catalyst for you, didn't it, subsequently? So probably one of the most useful, even if it wasn't all for TBA's benefit, one of the most useful shows to go to that set you off on your career. So quite amazing, really, sort of the way that linked everything together.
Yeah. So actually, we were digging through old machine images and stuff like that as well, and we've actually found an old playable demo of what ARL was, which was acceptable rate of loss, which was that old Star Fox demo as well. So after this, I think we're very interested in having some of these old software demos and stuff like that, just being initially pushed out so that other people can run them in emulation, because it's old, 26-bit code?
26-bit, yeah.
Yeah, 26-bit code. So it doesn't quite work on the newer 32-bit ARMs, but it does still work under emulation. And we're quite keen on releasing some of this old stuff as well.
Yeah.
So actually, when Alan and I were going up and down to Wembley, it was a long drive, wasn't it? It was from Bath, Bristol way all the way to London every day. You were doing the driving, but I do remember that my dad was getting quite concerned about why I was going up to Wembley 3 times over a weekend. He didn't quite understand that I was trying to find a job, I think. I was 18 or 19 years old at the time, so I wasn't really very good at communicating at the best of times. But as Alan mentioned, I think people did notice the demo that we were trying to hawk around, and actually one of the people who was working at Argonaut at the time, who actually worked on the proper SNES version of Star Fox, and who actually worked on the ARC chip, which was very similar to the ARM chip in terms of, you know, being a RISC chip. He noticed the demo and he said, you know, write off to us for a job, which I did. And then, you know, a few months later on, I actually moved to London and then started working for Argonaut at that particular point in time. It was a bit of a whirlwind. I was hoping, you know, but I certainly wasn't expecting to find anyone that would help me, you know, get a job at the computer show. But it was
quite amazing that
it was.
I can remember we were initially a little bit afraid that they were going to come and shut us down because our demo looked rather a lot like Star Fox. But no, things went very well, and I guess it also gave us the motivation to continue with what we were doing with TBA, as there was a very positive response to what was being shown, you know, during that show. And obviously alongside the good work that was done on Axis and Dragon Ball by obviously Matt and Jamie before us, so which I think I remember had quite a lot of good press and good attention at the time. So.
Yeah, so it's funny you should mention Dragon Ball. So this is the first slide of our games, just with a little screenshot here. So just to kick everyone's memory if they remember Dragon Ball. You know, to be honest, I don't remember it that well. It's basically Arkanoid, right?
Yeah, again, before our time. So, but plays very well. And I think there'll be a theme with the TBA games. A lot of the work was done on how well they play. So all of them should be good fun, and they should play really well and really easily. There's, you know, a lot of games that we've seen subsequently over the years. Obviously, you were in the gaming industry as it's become this almost monster of cinematic type graphics and things. And I mean, there's a graveyard of games that don't play well at all. And I think if there's one thing we did pretty well, I will say so myself, was the games played well and continue to play well if you pick them back up, which is, you know, testament to Matt as well. He did a lot of the testing on things and was very particular about the gameplay. So as we were developing these games, that was a big part of what we did. So anyway, we'll get to that in a minute. So
yeah. So I think the other game at that Acorn World show was Axis, which this is, if you're around or playing games at that particular point in time, it's much more recognizable, I think, because it was one of those games actually which had quite a unique selling point. And this was where the game screen would actually rotate around the player rather than the player, you know, rotating or moving around. So it was quite an impressive effect actually for our little ARM2 and ARM3 based machines at that particular point in time. I was very surprised. I thought initially that he was doing some kind of, you know, like cheap video playback or something like that, but actually, you know, once you get to play it, obviously you realize that it's actually a real-time effect.
No, it's very good. I mean, it's a standalone game with its own code space, as we've said on the slide. It wasn't connected to what we did later on, but no, very, very impressive game, and again, played very well. So.
Yeah. One of the questions that, sorry, I was going to say, you go, Alan. What were you going to say?
No, I was going to say, we obviously can see there was a question about sales figures mentioned on the slide, and we don't have those numbers now, but it's, as I said earlier in jest, but it's kind of true. TBA wasn't making money, so you know, the sales would have been in the hundreds at the most for these titles. They weren't big sellers, but yeah, I mean, to say more about, there's some good games. It was good fun along the way. So.
Yeah, I don't remember the sales figures either, and Alan would definitely be the person who can remember, because you did the day-to-day.
Not many.
I think eventually we started doing some retail sale and return as well, didn't we? But even then, the volumes weren't that high.
Yeah, we were doing distributors and also direct sale. It was we used to have the little office at home which had the stock in it, and we'd fulfill the mail order. We'd do that as well as everything else. So it would usually be obviously pre-internet originally, so you just get a letter through for a check for an order. So hard to imagine today, but that's
yeah.
So there used to be a regular thing to just fulfill any orders that had come through. Of course, I have to go and bank the check. So yeah,
mail order business, gosh.
Yeah, it's like the world's smallest version of Amazon in the front room. So
okay. So one of the kind of like key technologies that we were working on, because Alan and I are both very keen programmers, and we still are these days. Today actually, Alan was working on debugging some old code, and I'm always working on debugging something and such like. But one of the key pieces of technology that we were working on was tag and holograph, which is what Matt at TBA was really interested in. Basically, it's like a reusable graphics engine with at the time a very nice to easy to use editor, which allowed us to, because we had a consistent engine, it meant that we could fix bugs in one engine and then actually produce different styles and types of games with the same engine. And so we didn't need to reinvest a whole great big bunch of effort in creating new software all the time, because we had this bug tested and vaguely stable engine that we can actually use. It was actually the whole tool chain, so it included things like protection of the disks and all sorts of copy protection checks and stuff like that too, and compression and obfuscation and all of that kind of stuff as well. So it was a really useful thing to actually build up, because it helped us in our work eventually with producing several different games which were running along on kind of like a 3D theme, because 3D was getting really, really popular at that point. And it just basically reduced our workload.
Yeah, all the TBA games. Right? Sorry.
Yeah.
I was going to say all the TBA games we worked on together were released under tag and holograph. So yeah, it served its purpose extremely well. And obviously there was, as we'll come to, a third-party developed game also in the same system. So yeah.
Yeah, but it's not a completely unusual concept, because SGI when I was working at Argonaut, because Argonaut were doing 3D engine or 3D rendering libraries, SGI, Silicon Graphics, were actually working on a very similar concept, but for console games. So actually they were working on something called Firewalker, which enabled a games company to write game code once and then compile and target different consoles that were available at that particular point in time. So the old PlayStation and the old Sega consoles, but also PC games. It was using OpenGL in the background, but it was all wrapped up with C and C++ APIs. They chose to use C and C++, whereas tag and holograph was all assembly language.
Yeah, I mean that was probably, for those here who are developers, it's it's one of those things that probably feels a bit crazy today with the way high-level languages are and the power of computers, but it was a mixture of BASIC and assembler. It was the classic Acorn way to write software using the sort of inline assembler. So like holograph, we can see the pictures of here is BASIC with assembler support for the rendering engine. I've continued using BASIC in my career subsequently, much to the ire of many people who are C or C++ or C# kind of Java developers who don't really understand why, but it's certainly stuck with me. And you know, this for its time certainly worked extremely well as an editor for creating games. And as you know, as Martin's put on here, we've got lowering the cost of development. It certainly achieved that, and yeah, I mean, it meant there was, you know, the whole engine was reusable game to game and was tested across all of the different Archimedes machines. So it took a lot of our sort of compatibility problems and things away with the games. And you know, as we'll touch on later, there is a 32-bit version of Tag now as well that is running. So you know, we hopefully can, time permits, give something else back to the community as well shortly. You know, where hopefully we can get the games to run without the emulator on the latest sort of Pi 4 or whatever it is, you know, hardware. So so still adding value now. So maybe you want to talk about the other things, mathematics and such like, Martin?
Yeah, so actually I've got a few videos as well, but what we can do is that if there's time towards the end, then we can go and revisit some of these more technical detail videos, which go into actually what the editor looks like. But we're quite, you know, this is quite a large presentation, so we're quite wary about how much time there is going to be there. Hopefully there'll be a little bit of time at the end. We'll get Dave to give us a time check at some particular point. But the game demos and stuff, we'll definitely be showing some videos for that. But I think for the editor videos and things, we can always go back.
Sure.
Yeah, that's probably the plan. So this is the first holograph game, or tag and holograph game, which was Formula 2000 FTT back in 1994.
Do you want me to?
Yeah, you worked on this one mostly, right? I mean,
sorry, I just got a message from Matt bizarrely in the background. So.
Oh, that's a good coincidence.
Yeah. Yeah, so FTT was the first tag holograph game. So it was where it sort of sponsored, if you like, the development of the editors and everything. Obviously, originally imaginatively called Game Ed. I don't name software anymore imaginatively now. And then it's very functional. But yeah, we did. There's quite a lot of things with FTT that was kind of curious about. Obviously, trying to get it to run on an ARM2 was its own challenge for performance, which was part of the you know, the development of Tag, so that it was optimized sufficiently. As we've talked about, the code for these games, the runtime, it was written 100% assembler. So even all the overlays on the screen, the intros, everything is driven by assembler code, which is, again, probably slightly crazy. Look at that today, but that's how it was at the time. The key thing with this was, obviously, there's this tube track that kind of projects into the distance. And in this game, the track is generated at runtime algorithmically. There are no sort of models for the track sat in the editor. We do have some of the other things. We see the cars, all the overlay graphics, there's various things like signs that are next to the track and stuff. All of those objects were modeled ahead, but the track is generated at runtime. So it's like you see the sort of car there moving around, but it's not kind of going anywhere in the 3D world. It's like the track is moving. So kind of curious way it works. And then if you look at the picture closely, you can see that the detail reduces as the track goes into the distance in order to, you know, keep the performance high enough for the slower, you know, original ARM processors. We did, you know, this it was nice and colorful and 3D and fast moving, and it did run on the original Archimedes. So that was good. And you talked about, there's quite a long introduction on FTT. There's Bob and Ted and Studio and all these crazy things that, yeah, Matt and I had to go through and do all of there was commentaries and, oh my goodness me, all sorts of crazy things, and doing the ridiculous get ready go sound that was on the start of the game. I remember that was like in the dining room at my mum's house, recording that, I think, just shortly before the show when it was launched. All these crazy things are done at the last minute. So yes, there's all these things from picking teams to the studio scenes to, yeah, I mean, lots of graphics, and it's all assembly code that's driving the game.
I remember you and Matt actually acting out the script to make sure that the little speech bubbles and stuff, to make sure that the script was actually paced properly. It kind of like indicates actually Matt's work ethic on actually making sure even the small little details about the script, the little alien or doomers or whatever they are, making sure it's all paced properly.
I only just hear you over the music as well.
Oh, whoops, I'm on a mic. Let's see if I can adjust. How about that? There we go.
There we go. Yeah, so we have this idea of the studio here. So, two sort of crazy characters with the presenters of the TV show. There is actually a spec document that I've got all the specs for the games, because Matt actually wrote a spec for each of the games as to what he wanted, and kind of, you know, not probably the full storyboarding type things you'd have in a sort of proper studio, but it was, I went back and had a look, it was pretty good actually. It's better than most specs I've seen for things over the years in the rest of my career. There's quite a lot of detail about exactly what's wanted. So you're just trying to hang on to this tube, and if you go a bit too quickly, you're going to fly off. That's the gist of playing FTT, and you've got a time constraint on you to get a move on. These tracks get increasingly crazy as you move through a series of corners.
The thing about this game is that it reminds me actually a little bit like an inverted Wipeout that was on the PlayStation. So you know, on the PlayStation, of course, it was, you were inside the bowl of a track, so you couldn't really fling off or anything like that. But with this one being stuck on the outside, it was actually really tricky, because this would happen.
Yeah.
And you would just go flying off into the distance. And then if you're racing against the cars, of course, then they go zooming past you, because the computer cars were actually pretty good. Did the computer
there was
cars,
a fair amount of AI logic there for the just kind of adjusting the speed of the cars and various things. So, yeah, I mean, more so in BHP later on, but certainly there was a little bit of logic in FTT.
So.
Yes,
hopefully get back to the slide.
Yeah, there was the get ready recorded in the dining room. Amazing. I dread to think now what the microphone and the sound interface was at the time, but made it work somehow.
Yeah, indeed. I can't remember.
No. Well, if you remember, there was a load of gear from my crazy time in a rock band at school that we had lying around, so it would have been something to do with that. So
yeah. Okay.
So Cyberate.
Yeah, I don't remember much about this one, to be honest.
No, I mean, Mark, who sort of worked with us a little bit in TBA, produced this game entirely himself with his own code, etc. So Mark then subsequently helped us with a lot of the shows that we did. He organised a lot of the lighting rigs and crazy things we took to Acorn World and things afterwards. But he also did things like the copy protection code for us. various bits of music, such as for BHP. So again, helped to say, not been in touch with Mark for a long time, but if he does find this, then obviously he's welcome to reach out and say hello. But yeah, I mean, not much more I can add to Cyberate. Again, played really well when we saw it first of all, reviewing it with Matt. So yeah, it's good fun
My memory
game.
is not very good from this point in time.
Mm.
Command Ship was another one of our games, right? Well, not one of ours. It was one of TBA's games, right? But it was one that we didn't work on directly. It was developed by Robin Brooks. I quite like this one because it had different gameplay elements. You didn't just have to shoot things. You sometimes had to guide a little probe around and actually use the probe for playing like pool with things that you could collect and stuff like that. So actually this was and particle effects were nice as well on this, and the level progression was good too. Generally speaking, it was a nice little enjoyable game.
Yeah, I found looking through the files, I found all the letters to Robin and things, contracts, whatever, from the time. So okay, I don't think it sold many copies, but it was a good fun game.
Yeah, none of it did.
Mm.
The next game, of course, was Cobalt Seed, which was another tag game. This one was a larger game, a lot more complex to develop. It was a lot more coherent, I think. It felt more like a game with more love and investment and budget attached to it, right?
Budget in terms of time, for sure. Yeah, a lot of effort, and this was really where tag became a little bit more polished around when Cobalt Seed was being built, because it had developed with FTT and was probably a bit rough around the edges, but it got a lot more polished when we got to Cobalt Seed, which was yeah, obviously. Ooh, here we go.
I'm going to try and get video on the screen.
Another demo. Again, there was a big introduction on Cobalt Seed, which was a lot of the work that was done creating all these sequences. These are all, so a lot of games now you just run a video when you do the introduction, whereas with this is tag is rendering the entire intro scene in just with the engine in real time. So we had to sort of almost like storyboard this again, get the whole thing mapped out as to how we wanted it to work. This whole launch sequence again is just rendered in using the tag engine rather than being pre-recorded. Again, there's a lot of logic behind this in assembly language to generate all these sequences.
These days it would all just be animated and played back.
Yeah, I mean, you'd have just animation teams doing these things now, wouldn't you? I mean, there's no.
Yeah.
It's all in the end sort of ends up part of the game now. It's in the game code.
But this game was also, what was it, targeting the ARM 250 based machines as well, right?
Yeah, maybe ARM 3 with this one, I don't remember, but yeah, there was a lot of optimization done for sure to get this to run smoothly. 3D World, a lot of use of sprites, as we can see, as much as 3D models, again, for speeding things up.
It's so long ago now that I can't remember if the distorted floor was actually, the resolution was half if it was running on an ARM 3 machine or not.
Yeah, I mean, the way tag will do a lot of things in the way you can define the objects as to what quality of what you want where, and change the object as it gets further away, and all these types of optimizations. So, yeah. there'll be a lot of tricks going on, I'm sure.
Yeah.
Speed up. See, there's a lot of use of sort of scaling transparent sprites in this, is the creating a lot of the effects on the screen. So.
Yeah, this one was definitely the first real. I mean, FTT was the proof of concept, right? That one was definitely the proof of the model. Oops, my presentation's gone a bit wrong. A second. Let's try and get back. There we go. Yeah, technology is wonderful when it works and doesn't work. And then on to the next game. So this is an unreleased game. So this was actually, but this is acceptable rate of loss. It was a continuation of what was the Star Fox demo that we were showing around that Acorn World show a few years prior. So 1996 is kind of like when it should have got released, kind of. But eventually I was getting so busy at Argonaut that I didn't really have much time to finish it, which is unfortunate, but it's the way that these things go sometimes. Some of the original editor files that Alan was lucky enough to suck off his various hard disks and floppy disks and stuff like that, I noticed that it's got some of the old Star Fox, Wingstar demo assets were still included within the package. So yeah, you could definitely see that it started off as Star Fox, and then the ship was hastily redesigned, and you know, the gameplay was made a lot different to what Star Fox was. But yeah, it has a lot of potential, I think, right? And with the work that Alan's doing on getting TAG working in 32-bit, it would make it a little bit easier to start working on this again and actually try and get it at least to the stage where it doesn't crash. So actually, we've got a couple of videos that I can show. Yeah, if the presentation decides that it's going to let me show the videos. Let me see. So I think this first video is loud. There we go. This kind of shows the intro to the game. At the time, we were kind of experimenting, I think, with TAG, TBA branding in front of our games to make them look consistent, right? We were playing around with the idea. So the idea behind this is that if you're familiar with the arcade games from the dim distant past, then there was a game called Afterburner, which had a very similar kind of grid of 3D balls spinning around and morphing around, and I kind of like nicked the idea for that from that game because it's a very interesting game and I like that game a lot. So this is kind of like the intro. It just spins around and then it goes into some simple gameplay stuff. I'm going to go into the other video, which actually shows more, slightly less broken gameplay, because actually I don't crash that quickly in this second video. So this is the first time anybody has seen this game outside of me and Alan and Matt.
Except for me, when we were building other things every week, saying,
yes,
how far can we go before it crashes in ARL, which was our little joke of the week. So obviously the big difference with this compared to Cobalt Seed is it is rotating the world around, where Cobalt Seed stays at the same rotation.
Yeah, and this was being developed on my A3010 as well. So it was perfectly happy on an A3010. It played obviously much better on a strong machine, but the frame rate is pretty good for an in development version. Seeing this, it does really make me want to try and finish it at some point. and then it crashes because I don't know why it crashes yet, but you know, we might be able to figure out why. It's just when the health run out, I think, and yeah, you know, there are bugs in these things sometimes.
I can comment on your bugs.
Well, yeah, you can be the best programmer in the world, but you know, you still get bugs occasionally, right? Yeah.
So yeah.
So then we have Merc, right?
Yeah.
Merc was an interesting game for us.
As you say, I mean, it was another one's just good fun. Good fun game. I'll be honest, I don't remember too much. It's a long time ago.
I'm pretty sure that with this game there was significant quantities of alcohol involved because it's basically like a two-player game, right? You have to battle against one of your mates. I'm not even too sure if there was a computer mode versus mode, right? I think it was always two-player versus. It's so long ago that I haven't played it. But,
sure.
You know, it was fun. Quick.
Good fun.
Yeah. And I think this one wasn't a full price game, was it? I think it might have been on a budget release or something.
I think we decided we were going to release a sort of more budget range of games at this point, so
yeah,
slightly cheaper.
The next game was Mirror Image. So this was actually a tag game, but it was one of our first third-party tag and holograph design games and coded games by Ben Carter. So this is kind of like a bouncing around laser and mirror type game, but it was using the 3D engine to good effect. I think it was a really creative and novel use. We never really envisaged this style of game to be created with this tag and holograph framework, right? But that's what you get when other people take over and use the tools that you give them. They think in different ways.
If you look today and think what we would have done with the internet, and you could create a community, you could open source lots of things, get a lot of people involved in developing. I mean, Ben was the first example of somebody producing something in we had a sort of developer scheme for a while, which offered access and documentation, you know, full use of tag and holograph. There was a price list even for reselling some hardware like Acorn computers, various things, sort of trying to create our own sort of development community. And certainly, I mean, so we got to 96, 97, just at the birth of the internet. It's, you know, if we look today, I mean, I've been involved in quite a lot of things that are big open source communities. We were probably a little bit early with quite a lot of things during our time at TBA, but it certainly was an idea to get more people involved. And I was really impressed with what Ben did with this, because he took someone else's engine, he took our slightly eccentric documentation, I think it's fair to say, and managed to produce a really playable game using the 3D engine. And you know, it worked through how tag and holograph works. Obviously, it's all event-driven. You know, you put handlers on the end of events like you would if you were building a desktop application with holograph. So it's the tag sending you a, you know, before frame, after frame, object before frame, these things. So you can just trigger everything on events rather than having to actually build the sort of mainline and runtime logic for your game. You're just filling in the gaps. So much more like writing an application in the desktop, and Ben had picked that up and did a really good job of getting that game finished as well. So yeah, another game's good fun to play. Yeah, kudos to Ben. He took our engine and not very good documentation and produced something from it, which is the next thing after that we produced was something called TBA FS. So this was a departure from the games that we were doing. Why did we do this? Well, we felt that there was a gap in the market, really, Alan, right? Yeah, the file systems on the Archimedes, the compressed file systems, were all particularly slow and were really useful for archiving They weren't really a compressed file system you could use every day for things. And you know, I was also frustrated at times with the speed of the, you know, obviously it was very slow media from floppy disk to some of the, I've actually been recovering the old hard disks in the last few weeks, and even plugged into a high-powered workstation, Windows. Those disks do not run quickly, it's fair to say. Spin up and make a lot of noise, and then you're getting a few megs a second trying to read off them. And, you know, so there was also a case of trying to speed up the performance of everything. So for what it was at the time, it's a block-based file compression. So it uses image-based file system in RISC OS, so completely transparent to use. It's block-based, indexed with a tree structure, so it's got B tree in there, so it can always get directly to the block required for a piece of data, and read-write caching. So buffers everything that's going on as it runs, and you've got lazy writing as well, which you can configure, which makes it very, very quick. And it sorts into sequential writes when it flushes the buffer. So if you're writing to a floppy, you notice it is much quicker because it just writes in sequence all the way across the floppy. You don't get this thrashing around trying to write. But the same applies to even now if you've got a low-speed USB on a Pi or something, you know, where the write speed's terrible. It likes TBA FS writing in sequence for sure. But clearly the downside of lazy writing was always you could corrupt in a power loss or freeze. So you tended not to want to turn that lazy write cache up too far in terms of the delay to get it flushed pretty quickly. We did update it for 32-bit 2011. I'm running it now on a Pi 4, and it's very, 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 very quick. There was even a reader for Windows, but I had no idea where the source code is from years and years and years ago. Obviously, you put a note in there, Martin. There was a copy protection. Obviously, the 32-bit version was just released as it is without any of that, but. Yeah. It was some code that was actually identifying what the system was it was on, the drive, the hard disk, you know, size and geometry and God knows what, to try and lock itself to the computer. And we do remember the first version that we released at the Acorn World show had a bug, so we immediately had to send a floppy out. It's a replacement patch for everybody frantically when we got home. We had a recursion bug. I do remember that.
Actually, I think on that floppy, you very quickly wrote a little utility as well, right? TBA FS upgrade and stuff like that, just to just to improve the customer experience of getting an upgrade. It
was the joys of pre-internet again, in terms of most people bought a floppy, had to go home and actually get a load of jiffy bags and mail them all out of floppy in a hurry. Just
But it was a really interesting thing to work on. There was a very early image filing system version as well called LEFS, like Element FS, but it very quickly became TBA FS because Alan, working on databases and stuff, knew a lot more about how fast database access worked with B trees than ever I did. It was something that I didn't really know at that particular point in time. So, you know, we always, and this is a common theme throughout when we were working together, we would use each other's strengths. When things got a bit too tough and when one of us didn't know a lot about something, then, you know, the other one would always step in and fix the issues or plug those gaps. It was, I think, why Alan and I just worked very well together in those dim, distant days. Next slide.
Next one. So get to BHP.
Oh yeah. Okay, so this I think was our last game, wasn't it? BHP in 1997. So I had been working for Argonaut for
3 years,
for at least 3 years, maybe 4 years at that particular point in time. And near where I was working at Argonaut in Colindale in northwest London, there was a Sega arcade. And in that Sega arcade, there was obviously Daytona. And I wanted to do something like Daytona because it was the new, latest, whiz-bang 3D type racing game. And, I was always interested in car races anyway, and 3D, so it was a natural thing to try and do. We were actually trying to, get on and started using, don't know if anyone remembers the old Acorn Hydra hardware, which was the multiple CPU technology that Acorn were thinking about producing or talking about producing at that particular point in time. Transputer Hydra grid type thing, right? It was basically n number of extra CPU cores which you were meant to be able to use. I think Acorn were planning on having some kind of like PCI interface or something like this for this hardware, right? So we were keen on doing something like that because at that point in time, when I was trying to produce some prototypes, now I can actually show a video of one of the early prototypes as we're waxing lyrical on this. This is something that I was able to find from Alan's extracted hard drive stuff. So it's got this kind of data type feel. Rate. Yes. So the thing is that we knew that without extra hardware, without Hydra or anything, then it was going to have to work on strong arm. So this was always targeted towards strong arm and stuff like that. So this was one of the first, proof of concepts that we could actually throw enough textured polygons around to produce something which was a workable game. And all of this was, of course, done in tag and holograph and everything, and all of these car handlers and stuff like that was all little bits of code that we just had floating around for different camera views and all this kind of stuff. The real BHP game that was released looks a lot different to this, and the technology behind BHP grew once we knew the performance aspects of the strong arm a lot better, and we got to grips with how it worked in terms of caching and stuff like that. So actually the tracks, Alan did a lot of work on the basic tools for that, so I'll let Alan talk about the tools for BHP track generation.
Sure. Again, the challenge with a game of this sort is when you're doing this in your spare time and you've got to generate all these long tracks that are going to wind around like kilometers and kilometers of roads, if you like, if they were in real life. Is we didn't have a studio that could sit there modeling all these things for weeks and weeks and weeks. So we used we sort of pre-calculated these tracks from a descriptor file. So there's a basic application that generates all the chunks of track as models inside holograph. So we actually managed to get it to run last night, didn't we?
Yeah,
and it
very late last thing.
Yeah, and it obviously could run it really, really fast on the Pi 4. It just actually loads the models for each section of track into holograph. And it means you can just compile the thing and then shut it down. You don't have to save it with all these enormous amounts of models in the application. So, what that allowed us to do was iteratively create this track without all the pain of the trying to do this all as some sort of enormous world full of all these objects, which again the editor would struggle to handle. It would be too big. So you can load up each of these small sections of track as a separate object after they've been generated and look at it in the editor. Some sort of curious techniques used anyway.
Yeah, I was going to say it allowed Matt to basically fine tune and tweak all of the playability of each of the levels, right? Because they're not hand modeled 3D worlds. They are algorithmically generated, so you can make a straight longer, and you can open up a corner, or you can make it a tighter corner, and you can decide, where you wanted the 3D model trees and the extra signposts and the buildings, and everything else, right, as extra parameters, but it was all, because it was all algorithmic, just keep on regenerating and tweaking playability as much as you like. And this algorithmic generation actually allowed us to once we figured out the graphics, not the graphics, the mathematics for the collision detection for the side of the track and the gradient of the track and everything else like that, then the game pretty much fell together, right? It all gelled really well after that, I think.
Yeah, I mean, I think probably the thing people don't see with producing games, particularly when you've got an Acorn World, was always your hard stop every year for you've got to have it ready, was probably student syndrome always kicks in, particularly when you're doing it part-time. And BHP was, a lot of it was done 2 weeks before Acorn World when it was released. We spent a week camped in your flat in London, I remember. Matt came and joined us for a few days.
In the kitchen.
And one of the things that didn't happen in BHP, obviously it's noticeable the cars got quite limited dynamics in terms of sliding around. We with the time constraint, we had to sacrifice something in the build. So we made sure the game was finished. We made sure it played nicely in terms of the AI, but the full, sliding around sort of model that was there in the earlier prototypes was incomplete. So there was too many bugs and problems at the time. So that's hence why it's not there, which was, again, if there was lots of rainy days, then who knows? That code's still there. I'm sure we could fix the mathematics now. But
yes. So this is a racer which is a little bit closer to Ridge Racer rather than a drifting racer, which is what Daytona is.
Yeah.
Basically.
Absolutely. So.
But still, I think this is. I actually started working on an OpenGL implementation for Windows to try and read these files in and actually get them rendering, because I wanted to try and get BHP running in OpenGL. But I think what we'll do now is that we'll use Alan's work on tag 32, because I think even with software rendering, actually Alan's getting really excellent performance right from the.
Yeah, I mean the latest Cortex chip is so fast. DDR4 RAM, it's quite ridiculous trying to run it. Everything's too fast. It's just sort of. So I think if the thing with tag as well is we can change all the distances it draws and all sorts of parameters that could make BHP look a lot nicer. We can also up the resolution. Again, the engine isn't tied to a particular resolution. There are some issues with some of the sprites, but it's all in a virtual coordinate space. So at least the bits that are coded properly are in a virtual coordinate space. And so it should be possible to make an interesting 32-bit version of BHP. So we're just coming up to time, I think. Well, it's in on an hour, so we're just over an hour. So a few crazy pictures.
Back at the edge, aren't we, Dave?
Yeah.
No, don't worry about it. Take another 15 for the presentation if you need to.
We can rattle on through these slides. So this is just like a collage of photos from Acorn World 97, which was the last big show that we did, right, Alan? I think. Yeah,
absolutely.
Yeah. There's me in my Christmas jumper. There's Matt down here, looking puzzled. Alan, where are you? Oh, there you are. There's you in your Christmas jumper as well. Was it really that cold in Wembley?
I know in the shows were always in the October, November time. I certainly remember one show was unloading a van and it was absolutely freezing. I remember that. Yeah.
I don't know. Maybe
I mean, it was a lot of work went into exhibiting at these Acorn World. I mean, we'd gone back to something sensible here with a small little stand. You can see, not trying to build a games arcade as big as the one Acorn had built or something crazy, which we were doing at the time.
Right?
Yeah, it was always good fun doing exhibitions in its own kind of, I guess, sadistic kind of way at times, because if you're just the day after the show, you can hardly move, especially if you work in an office for the rest of the time. So,
yeah. So another thing that we've managed to find and resurrect a little bit was some old open sourced 3D library stuff. So actually, this was a departure from the purely assembly language written engine. This was actually a mixture of C, C++ perhaps, and a little bit of, well, some hand optimized assembly for the plotters. So we'll be releasing this at some point as well, relatively soon, because it doesn't need that much tidying, and actually it works already on the 26-bit machines in emulation. But this is again software rendering, but this is using 16-bit or 24-bit screen modes with transparency and lighting effects and stuff like that. So I almost forgot that I had worked on this many years ago. But code never really dies; it just gets picked up again and improved later on. And for this one, for this one specifically, the same code was actually used on a couple of different games consoles or handheld consoles. So the code, as it was actually used on Game Boy Advance for some prototypes that we were doing at Argonauts at the time, because Game Boy Advance used ARM, and also another unreleased title, but this time on the Nokia N-Gage, because again that one uses an ARM-based processor. So there's a little screenshot down there on the right-hand side. Actually, Frank Gaskin, if you know him, he does games that weren't. He picked up a load of the old assets and stuff like that as well, and wrote up the whole history of the software, the game called Eight Kings, which Argonaut never really released. But it's nice to go through this old code and actually see how we used to do 3D rendering in software rather than relying on OpenGL hardware and stuff like that.
Yeah, I mean, obviously, this at the end of this is when obviously the hardware was getting a little bit better. I don't know if I can't remember if we had a slide on the tech, but I can talk a little more if there isn't anything coming. Yeah, with Dino.
This is the last slide. This is the Dino demo, which was after that too.
Yeah. And obviously, the headaches with the original ARM chips, as anyone who's written assembler will know, is you've got two things really that you don't have. One is a divide instruction. So that doesn't help when you're trying to do any sort of mathematics. So we had, as everyone had, we had FN divide in the inline assembler, which was just used everywhere. And then there was FN divide _ some variant to optimize it a bit, depending on what you were dividing. And that's used all over the place. So that didn't help. And of course, no floating point. So everything's integer maths in tag. So we've got lots of definitions in the code for things like accuracy. So depending which game you were running, you could, if you knew the world wasn't particularly large, for example, you could stick the accuracy up, use some more bits. So all the code was written with these sort of variables set in the compilation, so you could adjust the accuracy. So I was looking at the tag in the last week on the 32-bit, and I could see all these sort of right at the top of the main file when you go to build it are all these variables which control all the major things, and there was like the angular accuracy, the maximum coordinate space, all this type of stuff is defined there. And that's all because really of not having a double precision float and and one of the things I did in 2011, which was released through the rule forums, was added VFP instructions to the basic assembler. It wasn't 100%, it was 99 something that it worked, but you could then include the floating point in line in the assembler, which was great. So again, if there's a lot of rainy days, there's potential to really sort some of the logic out in the middle of tag. And actually it would collapse the code, I think, by a factor of probably 10, 20 something easily, maybe more. Yeah. Because so much of the code is just dealing with the fact you've only got integers, you haven't got enough precision, and then you've got all kinds of crazy optimizations on top of optimizations to get things like Cobalt C to run on the old hardware, which again is sort of the simplicity of the ARM originally is why I loved working with it, and I picked the assembler back up in 5 minutes in the past week. I mean, it's so easy to work with, but the lack of some of those instructions really was, it's like a little bit of an Achilles heel as well when you're trying to do gaming, because almost everything is mathematics in this code, and it's, yeah, it just becomes a chore. I mean, we rewrote the plotters and the rotation engines and things so many times. I got the code backups going right back to the original builds of like GameEd and Tag, and if you go through that, you'll see this code just rewritten as we go, just to make it quicker. So maybe we learn something on the methods and the maths. So some, you say here, there's a lot of hand optimized ARM rendering in your later things. I mean, it's sort of hand optimized ARM everything in Tag, which is you've done here. I mean, you wouldn't do that today. You'd put the bulk of everything in C and then do the 1% that burns all the time. But yeah, in a way though, I don't regret basic assembler. There's still, having a full basic language to put logic in the code is still really powerful. You can loop out assembly functions in the code using logic, a bit like we generate the track in, BHP or FTT. You can do that in a way that a scripting language in a traditional assembler you can't really do easily. There's a limit to what you can code in those scripting languages. So so there's quite a lot of power still in that, even today. Based on, I've worked in the latest Visual Studio and other things in Windows a lot, and things have moved on a long way, particularly around debugging and profiling and things. But there's still some good things about both StrongEd and the basic assembler. So anyway, I'll let you talk the dinosaurs. If you want.
Well, I think this is the last slightly technical slide. So it links into what Alan was saying about optimization. So in software, with the last iteration of the Tag engine as it stood in software rendering mode, we were still able to basically do what PlayStation 1 was doing, maybe not with the full color range and with the full frame rate, but PlayStation 1 was doing at the time in hardware. But we could still, take the PlayStation 1 assets that were from a demo disc, and then because I had access to the dev tools, I could rip out the models and the textures, and then we could actually get it working on Tag as well. So this was one of the last demos, I think, that I did at that particular point in time, just to show people what we could do. And
there's a lot of polygons in that model. So,
yes, it's over 1,700 polygons, if I remember correctly. I think I'm dredging that 1,784. I think that's about right.
And they're textured. Presumably.
And they're all textured, and they're all morphed and keyframed, which was, pretty impressive. So 1 minute or 2 minutes, right, in terms of life after TBA. So I continued working at Argonaut until the company ran out of money. And then I did one more games company gig, and then I moved into enterprise security software and then banking technology and software.
Ran away to Singapore, isn't it? And then
I did.
That's it.
Yes.
So when I was running TBA, I'd sort of given up my A-levels and gone and got a job, and spent a long time in that same business, working my way up to IT director. And then after I'd done that, been in that place for nearly 20 years, I decided to go and see the world for some time off, and dealt with consulting, and more recently sort of CTO level global work for international businesses. So I'd say we learned, certainly for me, I learned an awful lot from trying to run the business at TBA, and then obviously having the opportunity to work at senior level across various businesses. So you say influence careers, goodness me. So certainly from my perspective, the work we did on making everything a model where we took the issues out of iterating fundamentally. People call it agile, they call it all sorts of things, but basically you're dealing with iteration and feedback loops in development cycles. That's the crux of actually building software really quickly and doing it well. feedback is essential, which is what that's about. And of course, to do that, you've got to make changing things easy. That's the rule that I apply all across everything I've dealt with in IT, from infrastructure to whatever. If you can't change it, you've created yourself a problem. And so you need to, know what you're doing, keep things fairly simple, work within simple ecosystems. Don't build some behemoth, great big stupid thing that no one knows how it works. And you work in a bank, you know how those are. And so loads of lessons from building the games in the way we did that have been fantastic across, professional career outside of TBA.
Yeah, basically that's it. I loved working on the machine because the basic assembler let us do all sorts of stuff that is, quite hard to do in less feature-rich assemblers at the end of the day, right? It taught us a lot, I think, about getting data from one place and not taking no for an answer and getting the solutions done, right?
You mentioned worth noting your video compression there on that slide.
Yeah, well, the Archimedes was actually used to prototype better video compression for Argonaut to use in their games as well, because the ARM chip was great at doing, video compression and playback and stuff like that too. So actually, we did a lot of work on video compression. It was actually used in a few commercial games as well. It was all software, based video decompression. So it had to work on, without any specific hardware. So, that was always fun too. So the last slide, I think, basically is what's next. So, I think we've touched on it, but, Alan's been working on extracting some of the code, getting TBAFS to work in 32-bit and getting tag to work in 32-bit. And I'm hoping to get ARL done at some point. But who knows?
Yeah, almost as of last night, the tag engine sprung into life on the 32-bit machine and actually could draw it's drawing everything properly and running some really basic applications. There are 26-bit code issues in the game, so they need to do some work on that. And then there's the music library, that's your fault, Martin, so I'll have to go back and have a look at that.
Yeah. It's crappy spaghetti code in the music library. I take full responsibility.
But yeah, it's interesting, and I have to say with the Pi 4B, the performance of RISC OS and the software is absolutely crazy. The speed things are going when you go back to how long it used to take us to do some of these things. I remember you were running a strong arm emulator, weren't you? And you ran the BHP track gen. And you'd set it running, and then about 10 minutes later, I set it running, and it was done almost straight away on the Pi. It was so quick. So it'd be interesting to see, and it sort of shows the way the operating systems is a lot of it's assembler as well. There's sort of crazy performance of things. So
and that's it.
Yeah. So
thank you to Dave.
Thank you. Yeah.
And thank you to Jasp as well for some of those YouTube videos. It was awesome looking through them.
Yeah, I saw those some time ago. It's amazing just to have that bit of history there that someone's taken a snapshot of the ball and they've spent all the time to take a snapshot of the game. So fantastic.
There you go, Dave. We're done.
Right, I've got a few questions have come in. So if you're ready to answer a few questions.
I'll stop sharing, shall I? Hold on a second. There we go.
That's it. Perfect. The one from Mike Rose, Pixel Blip, who I don't know if you know him, but he's quite a prolific artist on the forum. Does lots of 8-bit and teletext art. He's asking the 3D editor. I think you showed a screenshot of it briefly on some sort of collage page.
Yes.
Is that available separately? Does it output? What does it output? Is that outputting just to holograph, or is it a?
Yeah, I mean the holograph editor, which is what you saw the screenshot of, is designed for doing some 3D modeling, but its output is it compiles into a binary format that then the tag runtime picks up and is used to execute the game. It's got it's got an internal format, which is, say, it builds like an application package, if you like, that's got all of the resources in it and stuff that you can edit, which is how you're constructing your game. You know, you can drag in not just 3D models, but also binary files, music files, handlers, compiled code, this sort of stuff. It compiles all of that into a single package file, which is then what is picked up for use at runtime. So when we release the game, we would have, you might have a chain of package files that can execute each other and stuff. If the game, like there's different one for the intro and then another bit for etc. But so that's how holographs kind of working, is it's allowing you to create the resources, including 3D models, and then output them all for use at runtime in the game.
I'm guessing there weren't that many standards at the time. So does it interact with any of the other sort of, I can't remember what the 3D sort of standard files are?
Not directly, but I think Martin's had a converter that was taking in 3DS files and various things, weren't you, at the time? So
3DS Max, there are various different ASCII file standards that I was able to parse and pull in. Basically, it was whatever tool was being used in Argonaut at the time, and whatever conversion tools we had, you know, because there was always some mathematical, you know, matrix conversion for animation data and stuff like that. So, you know, all of that kind of stuff. It was just on a needs basis. We didn't try and support many different formats because it was always very quick to try and create a tool in BASIC to actually read something that you had and then spit it out into the file. Because the file format for holograph and tag was all documented anyway, so it was relatively easy to create new converters for that.
Well, that sort of brings me on to one of my questions. I've got the sort of file format for that. What was it? It was like a ASCII-based, easy-to-read format, or was it a
Binary.
Scary format?
Everything's binary.
Very compressed binary.
It is documented, so everything's documented. So the documentation's, it's not quite as tidy as Acorn's documentation, but it's the same idea. Basically, there's an API and you've got the registers, all the mapping for the assembler calls. And then there's file formats are all mapped out like byte by byte, i.e. this is how it all is. It's mostly, you know, 32-bit words that are all of the different components in the files. You know, it was relatively simple to read in, etc. So, you know, it is binary, but it's not the worst binary ever, that's for sure. So it's fairly tidy. Yeah.
That sort of leads on to another question of mine, is the editors themselves. You sort of touched on it briefly when you're talking about BHP, I think, that you split things up into chunks. How much memory did you need to edit one of these games? Was it memory intensive?
I was editing on a fairly standard RISC PC, so there wasn't vast amounts. Again, one of the reasons the track, the sort of overheads in these things, if you've got a big game like BHP, that track in its entirety, which we had a separate application in Holograph for each track, and we wouldn't save the application with the track in it. We would generate it into the application, compile it, and dump it, just because otherwise, every time you loaded it back up, you'd sit there forever trying to load all these objects back into the editor. So we had this sort of iterative process for avoiding saving the applications with the objects. I mean, you could, but obviously it just sits there chewing once it's saved.
It was a few megabytes, right? After it generated the track.
It's again, because it's binary, it's also got, it's you know, the BASIC deals with quite a bit of stuff, but the data, the format the data's in is all binary definitions that are handled by some assembly hooks and things as well as the BASIC. So it's pretty compressed in terms of size. It's you know, it's not like today where you might go to Visual Basic and start defining a load of things and each one's using Unicode, God knows what. You've got, you know, 50 gigs of RAM gone or something. If you try to read a big file in, you think, where the heck is all that gone? It's pretty small. Obviously, on a modern machine, on a 32-bit, I'm loading up, and obviously you've got oodles of capacity for everything. So, but it will need a few megs of RAM to do most things.
Yeah.
BHP is a bit of an exception with everything, just because the track is so big when it's when it's genned. You know, there was, oh God, there was 70 bits or something just to one of the tracks. We were looking at it last night, and you know they're fairly heavy on RAM. If they're, I don't even remember what's in my RISC PC, but I think it was upgraded to as much as it could be back in the day.
Yeah. I think the track pieces were 5 meters cubed or something, right? Something like that.
Something like that, yeah. Obviously,
quite small chunks then.
Yes.
Yeah. Yeah, each chunk's pretty small, and then it's all stitched together basically to make the track.
Maybe 10. Maybe 10 meters cubed. 10 meters cubed, I think.
Yeah. They're not big, so.
Yeah.
You know.
Right, we've got another question. So one from Demo J saying, great games, and he's just asking about plans for remakes and re-releases, which I think you've sort of covered.
My priority is to get things out 32-bit. You know, I'm sure there'll be a lot of people here who probably would love just everything dumped out 26-bit. If Martin feels like dumping some more things out in 26-bit, that's fine. I'm sort of curious. I have an enthusiasm again for this hardware, so I'm going to have a little play with the latest Cortex chip. And so far, the speed is insane compared to what I remember. So I'm just keen to get it running 32-bit. It sorts of runs now. Most of the 2011, most of the craziness with the different switching modes and all these things, that was all fixed. Tag was using every bit flag available in its optimization. So of course that broke everything when it was first tested. It was in the top of the program counter and God knows what ridiculous optimization. So it took all that out. But yeah, that's my priority. I don't know what will work fully easily. It's going to depend on hours, but if we can get everything 32-bit, I'll be happy to release it all and publish it all. It's I don't have any. There's no misnomer there now that it's worth trying to sell anything into this space. It's I would happily release it all for the community now. It's you know, it's what it is. It's a piece of history now. So.
And so new games. I'm guessing you guys probably don't want to spend months on it, but using the tag engine and holograph and stuff like that, how feasible would it be for like community people to start making their own games? Is it a massive sort of learning curve, or is
if you can cope with writing some assembler, then and you're familiar with working with the desktop, so you're used to event-driven systems, etc. You know, you understand application space and this sort of thing, and you'll be fine. You know, you'll be absolutely fine working with holograph. It's you know, it just needs that. It's got that little bit of an entry. You know, if you're just a basic programmer, you're not going to get very far because it's you know, it does require use of assembler because it's got. Well, you could possibly wrap it with C, I think, and put some hooks to try and do it, but that would be a little bit of a job to do the API modeling.
I actually, for the dinosaur demo, what I did do is that I did have C code, which was playing MIDI files at the top of memory, and all of the tag stuff was at the bottom of memory, and the two would play together relatively well. But the thing is that most of the workflow gears around having very small assembled pieces of handler code, which is just assembly code, right, which is produced by the basic assembler. And then it just saves the file and squirts it into the editor, right? So it's possible, but
yeah, I mean,
you'd have to play around a little bit with, you know, that was using the old Acorn C compiler or whatever it was. It would need to be memory aware for newer compiler technologies, but it's, you know, it's just at the end of the day, you're calling an assembly language with various inputs and expected runtime constraints.
I think there's still plenty of people want to do assembler stuff.
Yeah.
Anyway, I think, yeah, I'm not volunteering, but I know there's plenty of people out there coding. And for the old machines as well. So the 32-bit thing is great, but I think there'd be enough people if you just put the 26-bit versions out there who'd want to play with.
Well, I was going to say quickly, the tag version that runs in 26-bit and now runs in 32-bit as well. We have little demo applications and a little bit of skeleton documentation, which was enough for third-party games to be created with it. So yeah.
And is that all released now, or is that?
We can release that. That's not a big issue.
Release it again. There was a version that went on the RCI CD or something years ago,
Yes.
isn't it? Of holograph as well that was out there. So
Arcomp took all of our old stuff that we gave them and put it all on CD and basically sold it to people.
Yeah, we'll look to get things out there when we can. We've at the moment we've been literally going back through making sense of it all. We've realised that after all this time, our memories are a little bit wrong when it comes to most of it. So, yeah,
I think that's what comes from looking at code, which is nearly 25 years old.
Yeah. So we'll do what we can. I mean, with the time we have, but yeah, we'd love to get it out there. I mean, if anyone manages to do anything with the editors, that'd be fantastic. If they've still got some life in them.
Yeah, indeed.
Right, I've got a couple more questions. These are all from me, actually.
Yeah.
On BHP, what was the rough frame rate? It's quite hard to tell in the video because I think Zoom was making it quite jerky, certainly here anyway.
It's in the 20-25 a lot of the time on Stronghold. Yeah, the FPS.
I think it dipped to about 12 frames a second when you were on the starting grid and all of the other cars were there and the camera was spinning around.
Yeah.
Right. It was certainly
my
playable.
recollection is 20-25 if you're just out on the track and driving around.
And you were in mode 13, right, or whatever it was.
Yeah, I mean, it's fairly low. I think it's in CGA the res.
Yeah.
Yeah, we did have one or two that were running, and again, I'd have to go back and look at the code. I mean, there was a VGA mode set in the tag code when I picked it up, but that may have been me in 2011 trying to get it to run on a Beagle board, which didn't want to display anything most of the time. So because what it's doing now in the 32-bit one, and certainly just fixing it yesterday, is it's actually just taking the current mode from the desktop. So making sure it's 8-bit color, but leaving the same resolution so you know it's not going to fall off your monitor. And then it'll just scale the image. It draws it onto a buffer and scales it up onto the screen. So then it will make sure it'll just run on anything. You haven't got this problem trying to get these modes to display. Kind of nice if the operating system had an automatic screen emulator running in those modes. But yeah, that's probably beyond the time I have to start looking at that.
But I've got on here from Rob Coleman, and I had actually a similar question on my list. I know Axis was before your time, but do you know how they did the screen rotation and the scaling? Have you got any insights into how that works? Because it was so impressive at the time.
Yeah. So when I was looking at this, it's just basically an optimized DX DY with optional scaling bolted into it to pick out the pixels that you want it to. It's actually a very similar methodology to the scale, rotate, flip transformation logic, which is actually in the Mode 7 Super Nintendo screen mode. The ARM is really good at it because all it is basically adding the 32-bit numbers and in two coordinate spaces with different deltas, and then just using those numbers to pull out which map tile you want to display and which pixel in that map tile. It's literally
they render the screen sort of like in a raster fashion.
You just go horizontally and that's it. It's a very simple linear operation, and it's very doable in hardware, and it's very good for an ARM processor to do. That's as far as I can make out from looking at the code.
That's not quite impressive that it's going down the whole screen.
It uses
similar, Martin, to some of the tag mathematics in a way. I mean, everything's been optimized down into integers and adds, and you avoid divides like the plague. So it's just predefined lookup tables, and then you cache everything up in blocks in registers. It's the same method. It's just nice, tidy implementation, especially on an ARM2 or what it was way back then. I mean,
so if you do your maths right, then what you can do is that you can take the full register value and off the last few bits, and that gives you the inside tile offset in terms of X and Y coordinates that you want to pick out for a pixel, and it just lets you do a complete linear pass across and down the screen. It uses the principle of the fact that if you do calculations but only do that calculation once per screen pixel, then actually you can do some pretty good effects, right? Because you are eliminating overdraw. The only things that I think are overdrawn are the sprites over the top, and the sprites are actually, I think they're all pre-rotated and stuff. Right? They're just placed on the screen over the top of the rotated screen. But it's a very good effect. It makes efficient use of the number of registers that the ARM has, right? And the bit shifting and the the logical operations for extracting bits.
It's the inline shifting that makes an awful lot of things possible. Just rewriting the screen scaler last night, and it was just, oh my goodness me, I've forgotten I can just stick a shift on everything here and mix the registers up. I don't need all these instructions. Yeah, which, I've worked with x86 assembler, and you often need 10 instructions. It's just, wow.
Right. I had one about the event handling. I'll try and squeeze this one in. When you're doing like event-based stuff in a game, how did you do it? Did you fire off the sort of event handlers as they occurred, or did you tend to save them all up for the end of a vsync? Or
you have both. I mean, there is timer vsync running in tag, so you can do your movement logic either way around. So what we were doing was sat on like a 50 hertz or 60 hertz, I think it was 50 hertz in the stuff there, and it will always sit at 50 hertz, and it will then move the cars and all that sort of stuff on the 50 hertz. So the game is always running at that speed. You can get the odd shear and the odd thing if you get, catch the wrong thing at the wrong moment, particularly if the rendering is running much slower than the vsync. We tended not to see too many issues with that. And
double buffered it, didn't we?
Yeah.
You had double buffered values. It had collision events as well. So objects that were colliding would also get separate callback events for collision. So this let us do easy code for handling that kind of stuff.
Yeah, so there's a lot of events for lots of different things. So it'll give you the sort of pre and post object rendering and all this sort of stuff. So you can just stick your logic in the right place in the tree, if you like, as there's the frames being rendered. So you can sit and you will get interrupt triggered handler calls. Obviously there's like the mode switching and all the things going on in tag to try and make it safe. But obviously you need to know that if you're sat on an IRQ triggered event, that you've got to make sure you're not introducing some horrible bug down in the underlying renderer that's running for the once every 3 weeks it triggers when you're playing the game. But yeah, I mean, the documentation covers some of that, at least, I think, from memory. So I had a quick look at it the other day. Obviously, the idea was that none of those games have got almost like a mainline routine at all. Tag deals with that. So everything is done on event. So the handlers, there's a lot of them in the bigger games. Cobalt Seed and BHP have got a lot of handlers for all these different types of objects. Like you see, you're firing the bullet and the bullet collides with something and then the thing explodes, and there's just handlers on handlers on handlers doing all that stuff, layers and layers of things.
It's all very carefully, incrementally built complex behavior from very simple blocks of code.
Yeah. So each handler is pretty small, and that was always the idea, that you haven't just got BHP in one enormous basic file. You've got actually you've got all these nice small bits of code. Also, you can change that bit of code. You're not changing something else, which is developers always kind of nice. As you as a tester, you know that's very nice. You're not. You're not breaking the other thing straight away. So.
And then, what did you do about debugging? Because I know, like saying Visual Studio and stuff like that, and that it's now easy to debug event handlers.
Yeah.
I mean, you can still get yourself in a nice thankful where it goes around in a circle and tickles its own toe.
Obviously, most applications people are writing in Visual Studio and not inline assembler in the hardware generally, so the debugger's kind of nice. You can drop it on DDT and you can debug it. Certainly when I was doing all the 32-bit work, I ended up in the debugger there at times, just sitting on the crashes, trying to work out where the heck the crash had come from. But we were running lots of debug, like you always have to in these non-debugger worlds, with all sorts of methods like on-screen logs and logging to file and all things when you get a really nasty one that won't show. I mean, you just have to find a way to record the sequence up to the crash. There's no real way around that. Obviously, we do switch user mode the whole time and try and, at least Tag will try and friendly report errors as well. It traps them when it can. Yeah. So if it picks something up, it'll put an error message up and whatever. But I had a couple of bugs last night. I mean, it just froze the machine. It's classic Archimedes. It just boom, just control break, start again. Thanks very much.
Yes, I think in Tag, I do remember that if you were running in the debug version of the Tag engine, which came with the editor, then it would display with some extra debug information the object that you were working on and the handler that was running, and maybe the event that the handler was meant to be last processing or something like that. It was a bit like a guru meditation from the Amiga, but it contained a bit more, useful information from a Tag holograph engine specific point of view.
There was another point you mentioned there, is the events. There's also events that fire in the editor. So if you're trying to add a little bit of something into the editor, you can pick up various events there as well. It's worth noting. Because obviously there are times where things need to do things in the editor.
Right, I think we'll probably need to wrap it up. So coming up to 12:15.
We are done for time, aren't we? We're right on the edge.
We've had lots of people saying thanks for a brilliant talk. It has been a brilliant talk. It's kept us all entertained.
Thank you, Alan, too.